So welcome to PerfUp 5. Before we get into the whole business, I just want to take you to a quick reminder of what PerfUp really is and why we do what we do. So PerfUp is an initiative. Sorry about if there's background noise. But PerfUp is an initiative to bring together the best minds in the software and quality engineering to share knowledge on new trends and discuss best practices. So each PerfUp event will feature a panel of experts who will speak on their knowledge and their experience in the area to inspire individuals to tackle performance engineering. Each PerfUp will also explore topics that include more performance engineering concepts, processes behind it, tools, profiling, mobile performance engineering, but all along with their success stories and a few key takeaways for you, especially from our perf experts in the industry. This initiative also aims to bring perf enthusiasts together to develop best practices and share knowledge and awareness in the performance engineering space and beyond. PerfUp 5 is all about leveraging K6 for collaborative performance engineering culture. Today, we have two speakers, both representing Sysco Labs, to take you through this topic. And let me quickly introduce you to the speakers today. First up, we have Sahani Pereira. Sahani is a senior quality engineer at Sysco Labs. And along with Sahani, we also have Roshali Silva. She is a senior lead in quality engineering, again at Sysco Labs. Both of them will be taking you through today's topic, which is leveraging K6 for collaborative performance engineering culture. And a quick reminder for everybody to ask questions throughout the presentation. We've already shared a link with you, which directs you to a site called Slido. Please ask your questions there, and we will attend to them when we get to the Q&A session. If you didn't receive it, it's all good. I will drop it out here in the chat. You can just get onto the link and ask your questions there. Additionally, the QR code that you see right now also scans to the same page, and that's a small reminder to ask questions from Roshali and Sahani on today's. Wherever possible, please do go through the questions that have already been displayed on side. If you see the question that you already want to ask, you can upvote it. You can put a thumbs up near the question, and for that, give more vote to be asked. In the case that we are not able to go through all questions today, don't worry, we will also get back to you on a separate date with what is necessary. I think that's the introduction for everybody. I hope nobody missed anything from the introduction. It was very small, I assume. So I think Roshan and the rest of the content to come. Over to you, Rosh.
Thank you, Pava. Hope I'm audible.
Yes, you are.
Okay, let me share my screen. Can you see the screen, Pava?
Yes, we can, Rosh, we can.
Okay. Good evening to all of you, and welcome to the fifth edition of PerfUp. Thank you for joining. I think all of you know that we are going to talk about performance testing tool, which is called K6 today. And we know that you are very interested to know about this tool. That's why you have joined. So when we consider the audience that we have seen IT professionals from different backgrounds and from different companies are joining with us today. And also we have seen very enthusiastic undergraduates from different universities have registered for the today's session. Let's see what's a lineup for today. First, we will give a brief introduction about the what is performance engineering and what is performance testing. And then we will move for the K6 tool and for the K6 features and the K6 supported protocols and what are the limitations that we have seen in the K6 tools and how we have overcome them, and a very interesting demo on how to do the scripting and the execution on K6. And also we will go through the about the continuous performance testing and what are the benefits and outcome we can gain from this tool and continuous performance testing. Let's start with today's topic. Since we have different people from different backgrounds and set of undergraduates as well, we thought of giving a brief introduction about performance testing and performance engineering. It's just a brief one. Like if you are interested to learn about this more, you can Google it, or like there are a lot of references and you can search it. I think like in this audience, everyone knows what is software testing is. Then the software testing divided into two main categories: functional testing and non-functional testing. So this performance testing comes under non-functional testing. So if you do not know about non-functional testing, go and search about it. Since I'm telling this because we have a set of undergraduates who are keen to learn about this. This performance testing also categorized into two parts, which is server-side testing which we call as back-end testing as well, like which we are measuring the performance of the servers. And then the client side performance, which we are called as front-end performance as well. This one, like we are considering the browser level and the user feeling likewise. Then there's a I know that most of you have heard when it comes to performance testing, that is load testing. Some people are telling like both performance testing and load testing together. Actually, it's not the correct one. In performance testing, there are in server-side performance testing, there are a lot of performance testing types comes under the performance testing umbrella. Load testing, stress testing, endurance testing, spike testing. Today we are not going to talk about this. These testing we use for different purposes, but the tool we are going to use today can cover these testing as well. uh, so uh, like Now you may think there are a lot of test types and how we are going to test these. For to do the performance test, there are a lot of available tools in the industry. There are commercial tools as well as open source tools. We have tools to test both server side and client side. Let's see. If you have joined with us from the PerfUp 1, in the PerfUp kickoff session, we have talked a lot about the performance testing and the performance engineering. What is the difference between this? I'll have a kind of a brief thing why we have moved from performance testing to performance engineering. So earlier that that performance testing was conducted mainly by quality assurance engineers, and then it was started in the latter part when we are practicing the waterfall model. We started the performance testing activities at the latter part of the development life cycle. So we did the test planning, then the test scripting, test data creation, test execution, and analysis. So once the analysis is done, we think that the performance testing is over, and we complete it. And also people believe it was the responsibility of QA engineers to do the performance testing. But then with the new trends and technologies, with the new methodologies like agile DevOps, people have moved with uh, the performance engineering concept. So that in performance engineering, there are a lot of from the requirement gathering phase up to the production monitoring, performance engineering are involved. So for this performance, when we consider this performance engineering roles, it's a very important, and there are a lot of quality engineers, developers, SREs, DevOps engineers, even the products, BAs can involve in this performance engineering task. So I know today we have DevOps engineers, developers, and especially the university students who have not selected the tracks yet. So they can I think they are the most benefit people in this forum, because they for any track they are going in the future, they can use this tool, or they can get benefit from this. Then a performance engineering was a when we are practicing performance engineering in this culture, it's all everyone's responsibility to test the applications performance and deliver a very quality high speed in performance testing we are telling that it's we are testing the speed, stability, and the scalability. So all should be responsible for this. And also when we are practicing DevOps and Agile with the uh, current uh, environment, with the current industry uh, expansion, and with the use of new trends and technologies, there are a lot of releases going, right? Very frequent releases. They do not have time to spend much on doing the analysis part. Like they need to fix the issues quickly. So that's why the concepts like shift left testing, those came into the picture. So in shift left testing, that we are doing the testing in the early stage. Like earlier we do the performance testing once all the testing are done, and then once at the latter part of the life cycle, and one it's very closer to the production release. But when we are practicing this agile and the DevOps in environment, we can do the testing early, so we can identify issues early, and we can come up with fixes as well. And also we are practicing continuous performance testing with very frequent releases. So even we have bi-weekly main releases and daily releases as well to the production. So we need to test this very quickly, and we need to fix the issues very quickly. When thinking about those kind of environment, so we need the collaboration of each of our engineers, not only the QE engineers. So we need the software engineers support, DevOps engineers support, even the products and the BAs. We need, it's a collaborative work. So when consider that, if you have gone through the and if you have experience with tools like JMeter, load run, and a lot of tools, you need to have a specific knowledge about the tool. If we consider the JMeter tool, you need to have at least about what are the elements used in the tool, and how to use it. Likewise, then it will be a kind of a barrier to the tool experience may limit the engineers support to get this done. So we conducted POC, and for that we conduct the POC for a set of commercial tools as well as for open source tools. So after doing the POC, we have selected this K6 tool, uh, mainly considering the developer centric feature of that tool. So let's see about let's go to the K6 tool now. When it comes to the K6, so as I remember in last year, it was acquired by Grafana Lab. So you may know some may have gone through the Grafana dashboard as well. Now we have a lot of community support for these K6 tools, and quickly having features for this. So when it comes to the K6 tool, it has both cloud solution and open source solution. In cloud solution, that you know that it's a paid version of that, uh, and also the open source solution, which is available for anyone. So this is very easy to set up and do the scripting and testing. As you know that cloud, when we do the payment, that in cloud solution, we have a lot of options when compared to the open source solution. In today's throughout the session, we are going to tell like what are the limitations that we face when we are using the open source tool, and also how we have overcome this. Let's move to the tool. Uh, so uh, let's see what are the key features of the K6 tool. Like if you have gone through the tool like JMeter and load runner tools, it has a very friendly GUI. And when you have the knowledge about the tool, it will be very easy to go and do the scripting part. But here we have this is a CLI tool with developer friendly APIs. And the main thing is this is scripting is done like a code using JavaScript. So I know that most of you are very familiar with JavaScript, and it's very easy to learn. Don't worry, like if you are not very not you may think like now it's a kind of a coding. No, it's not like, even because here we have QE engineers, so don't be afraid, like this is very user friendly like coding we need to do. It's very easy to do the coding, and mainly that we thought of like using this tool because like we in the performance engineering culture, we are working with all the engineers. So it's very easy to get the support from other engineers, like if we find issues, and they can also get into fix the issues and do the testing part. Then the one of the main features in this K6 tool is checks and thresholds. So it's very easy to automate it. If you know the performance testing concepts, that the when we are doing the test results analysis, performance test results analysis, we are using KPIs response times, that which we measure the 90th percent response time, then the error rate and the throughput. These things we measure with the SLAs, and we consider whether these are within the SLA. These features, when we are using these checks and thresholds, we can easily automate this. And once the test is completed, we do not need to wait until we do the test results analysis. We can get whether the test is pass or fail once the test is completed. Let's see how we are going to do this in the demo, and also how we are going to use this feature when we are doing the continuous performance testing. And also the what are the protocols available for this K6 tool? It's mainly the HTTP and the WebSocket. And don't worry, that now we have extended protocol support when we are using the XK6. It's a separate CLI tool using the custom K6 binaries. Using this, we can do the testing for Kafka, SQL, likewise many protocols, extended protocols. If we take the main another, like what are the benefits that we can gain from this K6 tool is we can easily integrate with CI/CD. So now you know like all the things, even the scripting we integrate with tools like Jenkins. So this K6 also very easily can be integrated. And also as I told, like the main thing when we are having a collaborative culture, it's a developer centric tool. Even the developers, anyone, quality engineers, SREs, DevOps, anyone can go and do the uh, scripting very easily, because it's written in JavaScript, and it's kind of written in code base. No need of a element knowledge for that. And also it's very easy to collaborate. So we can upload the code in Git or any repository, and we can do the changes. Because like when we are having a tool like JMeter, then like it will be difficult to do all and go do the changes. And also we it's very we do not need, when we are automating this, we do not need like for to do the test execution, we do not need human resources. Like we can automate it and do the test executions as well. And also the main feature which I talk about in the check and thresholds, using this we can automate the test, and we can get the pass fail criteria once the test is completed. We do not need to wait until we are doing a detailed analysis. And the main one another thing is, we can the in the industry most of the time, like earlier when we are doing performance testing, we are doing the script recording and like a entire workflow. But now the industry is moving with API testing, even the API performance testing. So this is mainly like what we felt is like this is mainly suitable for the API testing. So okay, so now you got like some of the main features and uh, the main outcome we can get from the K6 tool. So since we are using this open, so we talk about the open source version, because like if anyone in this audience can go today and try this K6 tool. So when we are using this open source version, there are a set of limitations. So let's see how what we have seen as the limitation. So there can be some more limitation in this tool as well. Like these are the limitations which we have faced, and let's see how we have overcome this as well. So in this tool, like distribution execution is not available. If you know the JMeter architecture, that there's a distributed architecture with the master slave machine, but here like we do not have that option available. And also the data visualization, like using a dashboards and to get the like very graph results in a graph, and the test results report generation part, we can like get results only in the console. So there were those limitations. So if you have tried K6 at the moment, you may have also faced these. But like we didn't stop, like when we see these limitation, we didn't stop from that. We were able to find some solution for this. So we came up with a distributed load generation strategy, and visualize data, we have went with the our main APM was the Datadog. So we visualized some kind of data using the Datadog dashboards, because it's very we were able to easily integrate it with Datadog. And also we in our company we were using Tableau for the report generation and trend analysis. Like we are sending the data to DB and fetching from that. Let's see these into the details. Here, you can see this distributed load generation framework that we have came up with. So if you are familiar with performance testing, like tools like JMeter Load Runner, when we are running JMeter, that you may have number of thread groups to be run in one test. So we have one. If we have one test plan and different thread groups under one test plan. So here also, so like when in the K6 tool, it's like we are writing a script into one JavaScript. but like it's the generally availability. But in our context, that we came up with this module. Like this is kind of a one thread group similar to one module. Or if you know the tool load runner, there for a one scenario we have different scripts written. So this is kind of a module is in if we compare the load runner, it's one module is kind of a one script. Likewise, we have created different modules because in our context, we have to write one script, script for case script for more than 50 endpoints. So it's like, and we are running it for a very large number of TPS or the load as well. Another one is like you know that when we are running a JMeter from a one load generator, it's not supported for a number of threads or virtual users. But when compare the JMeter and the K6, when we set up K6 in a one machine, we can run more than for a like higher number of threads using one load generator as well with their infrastructures. When we came up with this module concept, we assign one module into a one load generator. So then we were able to run it for any number of load or any number of endpoints which we need. So it's you that we are using EC2 machines as the load generators. So then it will be very easy. Like, and if you want to, we were running it using Jenkins. So like if you have a kind of a large module wise, but we can easily select one and like when we need to run only one module, we can select the one module and do the execution as well. So likewise, we came up with a distributed load generation strategy. But like when you come to come to your context, like you can do some adjustment and come up with. So when we have different modules, we are like combining it using the using one main JavaScript. So this will be tell like more details will be tell during the demo as well. And also like we as I told, like for the test results analysis part, we are integrating it with Datadog and Tableau. But like that since now you have Grafana, because it was K6 was acquired by Grafana, you can get the more details from the Grafana as well, because now they have a lot of templates created in Grafana to use the K6. So the this is the Tableau one. Like we can get the Tableau dashboards. Like in different in Tableau, when we are doing the Tableau, so as I told, like there are we have the different KPIs like response time, error rate, throughput. We can get the trending graphs using this, and also like we can compare results between two releases. When we are using the this trending analysis, this is not only for engineers. Like even the products BS business analysts can get the results from this trending dashboards and can predict what kind of performance that will be like when there are frequent releases, how it will impact in the production in future. Then we have integrated our APM was the Datadog. So we have integrated it with Datadog, and like we can get the server resources like CPU, memory, and like error logs as well. So that's pretty much about the tool. Let's move to the demo. Like Sahani will give a like tell how to do the scripting and execution. Over to you, Sahani.
Thanks, Roshali. Hope you can see my screen.
Yes.
Okay. So now you must be eagerly waiting for the demo. Yes, let's go for that. So for this demo, we are using this pet store server, which is publicly available. So in this demo, we are showing you the structure that we are following. So there is no a must rule or mandatory thing to use in this way when we are using K6, but this is a structure we have came up with working some time with K6, and this has been easy for us to maintain a large test suits. So I'll explain you on that. So hope you can remember that Roshali explained you about the features of cases. So one of the main advantage of those K6 features is that we can collocate K6 performance scripts inside the application code base itself. So in the application code, we can create folder called performance, and we can store it in the root level of our application code. And so here is how our folder looks like inside the performance folder. So there are three folders available. Those are data folder, lib folder, and the test folder. In the data folder, it includes the test files we needed for our test scripts. And these data files can be in any format like CSV, JSON, whichever the way it is suited for the test scripts. And then we have the lib folder. So in the lib folder, we include all the helper files we needed in our test scripts. And then we have the test folder. So in this test folder, you can see we are including our test files. But here you can see there are three another folders. So when we go to this Swagger, you can see there are three categories. So we have created three subfolders for those categories in this folder, inside this test folder. The reason for having those subfolders is maintainability of our scripts. So assume you might also have an experience of having hundreds of APIs in a server. In such a situation, having all of those test scripts in a single folder will be a very hard thing to maintain. Example, if you need to find a test script in such a folder, then it will be a very hard activity. So for that thing, if you have this kind of subfolder structure, then it will be very easy for you to maintain any of your large test suites. So if we go to this test folder, a subfolder, there are test files. So inside this test file, we have APIs. So we always try to have one API for one test file as much as possible. Because we are trying to do that to easy for us to maintain and define the load patterns and those things. We are trying to having one API for one test file. But there are scenarios we have to add more than one API in a single test file. For example, get a situation like this. We are adding a pet to the store, and then we are updating a pet, and then we are deleting a pet. So in such a situation, if we are going to delete a pet in a script, that means we have to have a pet available throughout the test to be deleted. So if we can add both the adding the pet and the deleting pet in a single script, then throughout the test, we have a pet to be deleted. And also with this adding pet API, we don't get the unnecessary database growth throughout the test. So in such a situation, we can have all those APIs in a single test script. So for that also, there can be other ways to do. I'm just giving you an example about where are the situations we have to add more than one APIs. And then we have the main file. So the reason we have main file is when we are running the test, we cannot run to get the realistic behavior, we cannot run one test file because we want to run as a test suite to get the realistic production behavior. For that case, we have a main file. In that, we combine the test files in that folder, and we run all of them together in a single test. So every subfolder, we have a submain file, and also for this folder, we have a big main where it includes all the test files for this service. So here, which includes a load test suite. And hope you can remember that Roshali spoke about distributed test execution. When are we going to need distributed test execution is when we have lots of APIs where it is not enough to run them on a single instance. And also in K6, it's only for single instance, it's only capable of running 300,000 TPS for a single instance. But there can be situation where we have more than that TPS. So in that case, we have to make a way to run, but it's a limitation of K6 in open, so that we cannot do distributed test execution. So in that case, how we can overcome is we can run each of these submain folders, submain files in the load generator, and run all those load generators at once parallelly. So we can run test suite as fully with the distributed method. And then we have this config file. So in this config file, we have all our test configurations. Here we have defined the durations and the SLA values, and also our TPS, time periods, all these are defined here. So if there are any value that needs to be passed to all our test scripts, then we are defined here as variables. So we can access throughout those test files using those variables rather than giving the separate values. So this is the structure we are using. So now let's go to script and API. So by now you know that K6 does not have a GUI. So we can use your favorite IDE for scripting. So mine is VS Code, and I'm using VS Code for that. And also in most of the IDs, they have plugins and extensions available for K6. So when you're scripting K6, you can use those and enhance your scripting experience with K6. So for today's demo, I'm going to script this get store orders order ID API. First, let me try it here. So we can get the response like this, and this is how we have to send the request, and these are the headers. Okay, let's see how we can script that. So when we are going to add it, first we have to, in our folder structure, we have to add the script in this test folder. In this test folder, and this is inside the store category. So we have to add it in the store category and create our test file. So we can give the name. This is how we are naming. This is our naming convention we use. So we can give this a method name first and the latter part of the URL. So when scripting K6 in a test script, there are 4 stages, 4 life cycle stages in K6. There are init code, setup code, PU code, and tear down code. So in that, the init code is where we do the initialization part. That means this is where we load the local files, import libraries, modules. So this init code part is called once for each VU. And then we have the setup code. The setup code is where we do the pre-processing part of the K6, our HTTP main request. And from that, we can share the data among VUs. So this is called only once per a test. And this is executed at the beginning of the test. And then we have the VU code. So this is where we have our test function. So this will iterate among the test. And then we have the tear down. So tear down is the code that will execute at the end of the test. And this will also execute only once per a test. So this setup code and tear down is optional. It only we need to add it if the script requires any pre-processing or post-processing. Otherwise, we can work with this init code and VU code. And in the VU code is a place where we add a HTTP request where we are going to test. And in the init code, we cannot add any HTTP request. But in the setup code and tear down code, we can add HTTP request, not what we are doing the test, but any pre-processing, anything HTTP request we needed, we can add it in the setup code and the tear down code. And we have another part of basic step, that is options. So options is a place where we configure our test run behavior. So in the options code, we configure number of virtual users, iterations, and thresholds. Those things are configured in the options part. So, okay, now let's start scripting. So when scripting, first we need to add our HTTP request. So for that, here we in the init code, we have to import the HTTP module from K6. And then we have to create a function in the VU code. So here we can create export const. So for the naming, we try to give the same name so that it is easy for us to maintain. It's to order ID. And here we can give our request. So we are getting this HTTP module, and this is a get request. So here we are using get. And when you go to this, you can see this is expecting two parameters, that is URL and the params. So for the URL, we can get the URL from here. And then we have to give the headers. So for that, we can give headers. So the headers are accept the application chips. So we can give it here. And then we can give a tag here. It's actually not an must thing, but it's better if we can have it, because when we are doing a monitoring part, this will be useful, and I'll show you when we are showing the Grafana how this has been useful. So here we can add the name, tag name. So we can give the same URL where we can identify our API. So we can give the latter part of it, store order ID. And then we can pass it here. Okay, now you can see there is a value here. So that is the order ID. So in when we are doing testing, we cannot use the same data throughout the test. So we have to do the data parameterization. That means this kind of values, we have to make them into variables where we can pass values or the change values between the test runs with the appropriate value for this. So if it doesn't do that, if we pass only this data throughout the test, then our test result will be not correct. Our realistic behavior, we cannot get it, because the test results can be best or worse than the better or worse than the actual behavior. Because sometimes this value can be cached and we get a better result than production. Or if we use the same data, the data can be get locked and we get a worse result than production. So for that reason, we have to parameterize this value. So for that, we have to, you can get the values into variables, and we can get those values from a test file. So we will we have to add that in the data folder. This data file for this, we can add it in the data folder. So here is this file. So here we have added a small test file, and then from that we can get the values. So when we are importing a CSV, passing values from a CSV, in cases we have to need to get an external library called PerfUp. So first we need to import that PerfUp. So we can directly grab it from here. This is the yes, and we can get it here. And then this is the library we want. And here, and the version is 5.1.1. And then there is another concept in cases that is shared array. It is actually, if we can use that shared array, it will be really better because it's not a must, but it's better to use it because the shared array is a concept called array-like object. So it shares the underlying memory between the VUs. So when we have the shared array, the function executes only once. So and it saves the results in the memory. So that when we need the value, we doesn't need to load the CSV over and over again. Rather than that, we'll execute this only once and save it. So when an element is needed, a copy of that value is given by this K6. So for that, we will import shared array. So for the time being, I'm copy the how the data is taken here. So in this way, we can get the CSV file. And then we have to get a random value from the CSV. So here we are going to pass try to get the random value first. So in that case, we have to add the first random value. So we are generating a random number. So you can see this is a very simple JavaScript that you can there's nothing complex thing. You just using the simple JavaScript, you are taking a random value within the length of this CSV rows, and then we are passing it here. So here we are getting this, and we get the random value from the CSV. So the header is order ID. So here we are adding it here. So this is how we pass the random values. And then we have to, after that, we have to add the options. That means we have to give how we can configure our test. So for that, we can give here in the options we are configuring. I explained earlier as well. We are configuring both the VUs and iteration. So you might be thinking about what are the VUs? VU is virtual users. So in virtual users, so what is virtual users is it's simply the name what it says, virtual users. So actually virtual is an emulation of user performing the script. So when we need to create a certain load, the virtual users will spawn up in the K6 and it will get the target load. I mean the virtual users will spawn up until we get the target load. So then first we have to add the scenarios. And then in the scenarios, we have to give a unique scenario name. So we are giving this name. And here, then we have to give the executing pattern. So for that reason, we have to give executor. Executing pattern means what pattern do we need to run a load test. So for that, we have to analyze production and get the behavior of the production environment, how the load actually behaves in a production, and we have to mimic it in a test. So there can be a situation where the load is gradually increasing, or there can be a consistent load throughout the time. There can be a different load patterns. So when we analyze in our production behavior, in our production, it has a pattern where the load gradually increase and then the increased load will sustain for some time and then gradually decrease. So there are so from the executors we can get we are able to show that or mimic those patterns. So there are a lot of executors available in K6. For our case, we are using ramping arrival rate. So the actually executors are the K6 execution workhorses of K6 execution engine. So there are different. We can schedule the VUs and iterations differently there. So in the ramping arrival rate, executor is where the variable number of iterations are executed in a specific time. So in our case, we have to gradually increase and sustain the loss. So that kind of iterations are variably defined with this ramping arrival rate. So actually our pattern is kind of that velocity graph of pattern. So we can uh, mimic it with using this executor. I'll explain it further when we're defining the stages. And then we have the exec. Exec is the this function which we are calling. And then we have start rate. So for that, we'll give 0 and I'll explain it further to you. That means at the beginning of the test, the rate should be 0. I'll explain it further later. And then we have time unit. For the time unit also, for now, I'll add 10 seconds. This also I'll explain further in later. And then we have pre-allocated VUs. So for pre-allocated VUs, we normally give it as 10. And for the max VUs, we normally give it as 100. What are these? The pre-allocated VUs is when we start the test, the number of VUs allocated are 10. And it can go up to the VUs can spawn up to 100. That means we at the start of the day is 10 and we are giving some we are defining a target load which we need to achieve through in the test. So the VUs will be spawn up until the test can achieve those target throughput. So why we having this maximum VUs? The reason is if we there can be some situation where the system got issues where we get very high latency. In such scenario, if it doesn't have maximum VUs, this can like gradually increase the number of virtual counts, like unnecessarily grow, and it might be can crash the system or get some unnecessary issues. So for that reason, to avoid such scenario, we have added the maximum VUs count. And then this also can be different with your test. Sometimes the max VU count can be higher depending on the throughput. So it has to be something it needs to get with the throughput. So for now, I'm adding 100. And then we have stages. Stages is the place where we define our test or the test pattern of how the load pattern. So I told you we have that kind of velocity graph type of pattern. So let's see how we can configure that. So first we have target. So the first, let's say it's target 12 and the duration we give it as 20 seconds. So what this means? This means when we start in the test, the rate is 0 and the rate will go to 12. The 12 means the 12 transactions per time unit. This is not per second, but per time unit. So the time unit is 10 seconds. So that 12 requests will go in 10 seconds. In case if it doesn't allow to have decimal values. So therefore, that's why we have this time unit concept in cases. So for example, if you have the TPS is 1.2, that means 1.2 requests per second. In that case, we cannot add those decimal values. So how we configure is we giving 12 requests per 10 seconds. So what we are going to achieve is during 20 seconds, the rate should grow from 0 to 12. So in performance testing, the load gradually increasing, we call it as ramp up. So this is the ramp up stage from 0 to 12 transactions per 10 seconds. Within 10 to 20 seconds, this has to be happened. And then I told out then after that in our system the load sustain for some time. That means we call that hold duration. So that means now the load has achieved 12 and it will be sustained till 12. That's all duration. And then we have 0. That means up from 12 it will be decreased to 0. That means from 12 the gradually decrease to 0, we call it ramp down. So this is how our load pattern works. And then after configuration of options, we can give a checks. In case if there is a concept called checks, that means we can like find where we have with our we can check like it's kind of assertion we can check in this. So for now, for this case, I'm checking whether we're getting a status of 200. That's what I'm going to check with the using this check concept in case it. So in here we can give check. Sorry, can give check here, and from here we can pass it in this way. First we have to give rest, and then here we can give a type of message. So in here also it's better we give a API name so that it will be easy for us to identify when we are running multiple tests. So and then we say status was 200, and here we get this, and this is how we need to configure it. Sorry, this is how we can configure the checks. So let's run this and see. Sorry, there is issue with the network connection or something. Let's see. Adding this again. Yeah, it's working now. So we can see the test is running. And here, when you're running the script, you have to make sure that you are giving the correct path. So we are in this vector, so we have to give the path to our file. And we can see our test has to be run in 60 seconds. 20, that means this is total duration has to be run. So that means 60 seconds. So here 30 seconds has been executed. And this says the number of completed iterations. And yeah. So here also it shows our configurations, like what's the maximum we use and scenario, how many scenarios are there. Likewise, we get the ones. Yeah, the test has completed. So we can see this is how a check works. So this is what the check message I given. So it is printed here. So that means 50% of the request has get 200 and 50% hasn't got the 200. That is what it shows here. So now this is only with check. So we haven't had thresholds yet for this. So let's see how we can add thresholds and run this test. So for the time being, I'll just add the script which has threshold. So here we have different why first I'm explaining you why we need to have thresholds. So threshold is a pass-fail criteria. So in thresholds, we are defining our expectation. So what is the expected criteria? So if this test does not meet our condition of the threshold, then the test will finish with the fail status. So here we have configured our latency, request count, and failure rate. That is the threshold we are looking in a test. So we have configured those stuff with the SLA values. So here we have configured our request count. How we have configured it, we are getting an expected request count and we are comparing whether we get the expected request count. So how we compare that is, um, we have in our helper file, here we have we are getting the expected request count by getting the throughput time unit during the whole duration. When we are taking the request count, we don't consider the ramp up and ramp down because it is a bit hard to get the uh, request count here, ramp up and ramp down. So we are only getting the request count in the whole duration. So we are calculating that what should we get, and we are adding a tolerance rate here because we can never get the exact number. So we are getting 10% of plus and minus to the expected rate. And here after that, so we are comparing with the expected rate. And then first I'll run the test. So with the time, I'll explain you the thresholds. So there are 4 types of thresholds available in K6. That is counter, gauge, rate, and trend. So the counter is where we have the cumulatively sum of added values. So for the request count, we use that counter. So we are taking the whole here, we are taking the whole duration values, whole duration request counts. And then we have the rate threshold. The rate threshold stores the minimum, track the percentage of the added values that are non-zero. So for the failure rate, we use that rate. So here we are, if the status is not to 100, then we are adding it and we getting the percentage of failures. And then we have trend matrix. So the trend matrix, we have getting the calculate the statistics on the added values like minimum, maximum, average, or percentile value. So for the latency, we are taking the 90th percentile. So here we are comparing with the SLA, that is 750 milliseconds. So we compare with our latency is 90th percentile value is lesser than 750 milliseconds. So I hope you can remember that Roshali spoke about automating performance test with cases. So this has been a very good feature in cases where we can where we can automate a performance test, because if one of those thresholds has failed, the test will finish with fail status. So the test will pass only if all the thresholds are passed. So it is a very good feature in cases when it's automated. So here we can see this is the checks. These are the thresholds. So you can here see, hope you can see these thresholds, the failure rate, latency, and request count. The failure rate threshold has failed and the request count threshold has failed, but only the latency is passed. So at the end of the test, it says some thresholds have failed. That is how we have this test automating part with thresholds. So after that, I'll show you how we can run a main.js file. So this is our main file. So here we can I'll quickly go through how a main file should be added. So each subfolder we have main file, and there we have here we have a consolidate options like this in scenario collection and threshold collections, and then we can pass the our test execution. So there can be more than one scenario, more than one function. So if there are more than one function, then we can call them here with this main file. We can call each of them here and run all of them together. And then let's run this main file with the Grafana integration. So here I'm integrating with Grafana. So you can see it. I'm sending the data to InfluxDB, and we can visualize it in the Grafana. So you can see in the real time the data is coming. So you can see the data is passing here in the real time. So there can be different parts available like virtual users, request per second, errors, checks, request duration. And also here we have the URL. So I mentioned you that we need that tag name. So this is where we can identify because with this tag name. So here, for example, you can see here, there is a tag name called get find status. So you can see these things are added from this. So that's the reason we need to have a name, because other than that, in URL like this, there are different status are available. So otherwise, if we doesn't add the tag name, we get all these URLs one by one. So we don't want to get it. We only want to get it as a whole. What's the latency or what's the error rate we get for one URL, one API. So that's why we need to add that tag name. So here we have the data. So in Grafana also there are a lot of because you know that K6 is Grafana is owned by K6 now. So so Grafana has lots of already implemented dashboards available. So if you go to Grafana, there can be different load testing dashboards already implemented one. So you can use one of these, or else you can create your own customized one as well. So here you can see that results are coming in Grafana. So Rochelle also mentioned now this K6 is a developer-centric tool. So and also this is in JavaScript. So you can customize your K6 suite with the way you want. So here we showed you simple way of doing it. And so you can use our structure as well if you feel it's suit for you. Otherwise, you can come up with your own structure. And also, we can use a lot of use helper files, modules. With this, we can use like reuse same code with the module and a lot of helper files. So we also have added more than that, but here we showed you some simple way because we doesn't want to get it more complex. We want you to understand this easily. That's why we showed you simple structure. So with that capabilities of JavaScript, we can do a lot of customizations and we can do a lot of things in the cases. So this is what we have showed you. So you can enhance your one based on that. So now I will give Roshali to speak about the more interesting and important stuff that we can do with cases, how we can do cases in an interesting way. So Roshali, over to you.
Uh, Hope I'm audible.
Yes, yes.
Okay. Thank you, Sahani, for doing a great demo on. I think you now know like to start on how to do the scripting using K6. In my previous slides also, I talk about the continuous performance testing. So like when we are moving with frequent releases and like doing daily deployments, that continuous performance testing is very important. In our context, we have automated this continuous performance testing. So if you have joined with during the SLASCOM summit, which was recently happened 2 months ago. We talk about this a lot. So we will like give a high level idea about how we have automated this continuous performance testing. You actually we have used this K6 features to do this. Okay, using uh, this is the K6 test framework. We have as I told in the K6 features, it's very easily integrate with CI/CD. So we have used Jenkins to integrate this. So when it comes to the K6 test framework, we have run the K6 on top of Docker, and we have a separate K6 library used to run the where we keep all the configurations and everything under K6 library. And we in this one once we are running the test using the K6 script and through via Jenkins. So once the test is completed, we are sending the test result to dashboard DB via dashboard API. So when we want to do the test results analysis or trend analysis, we can just go to Tableau dashboard and select the what is the test execution ID, and can get the test results. We can get the response time, then the error rate and the throughput likewise. And also we can do the compare two releases or like the trend analysis using this Tableau. Also we have done this once the test is completed, we are using these checks and thresholds and sending whether the test is pass or fail to the teams. So then the teams can in teams any engineers. So in our teams we have developers, QE engineers. So anyone can have a look based on the test results, and then they can respond to that, what is the issues, and they will be easily come up with a fix, rather than uh, waiting at the end of the stage to do the testing and get the results. So it's we can collaboratively do the performance engineering parts. Also, once the test is completed, and during the test also, we are sending the test results to Datadog, so we can do the real time monitoring as well. So this is only the K6 test framework part. We have done this we are running this test. This is a kind of a test regression suite. We came up with a regression test suite in our context, and we have scheduled to run this early morning. Then first we do the deployment from the develop branch. All the services are deployed from the develop branch. So we are getting the what is the recent things, and in the development, and we are doing the testing. We are doing the here, it was not mentioned, we are doing the load generate, first do the deployment, then also we are for some test data purpose, we are taking the production snapshots and restoring the database. Everything is automated. So once we go to work on the next day, we will get the test results. So the test will be executed, and we will get the results will be sent to the relevant teams, because we are running it as a regression test suite. So the teams can have a look whether the test is pass or fail, and then if there are failures, they can quickly respond to that and fix the issues. That's how we came up with this automated this. So let's see what are the benefits that we have gained after automating this. With the time constraint, we are doing it quickly. What are the outcomes and the benefits we gain using this K6 and also the continuous performance testing? So the main thing is we can identify issues early. So rather than waiting until the latter part of the development life cycle, we can do the it's a kind of a shift left testing. And also the since we are doing a regression test suite running, and the load generators only setting up when we are running the test, it's like cost effective. We can reduce the cost. And also since we are automated, is less human effort. So we do not like I think like if you some there are some engineers doing testing, they need to monitor during the entire test. But in this context, it's running early morning, so we can reduce the human effort, and also the environment. We can time saving, because we can during the daytime we can do like further testing and like further analysis part, and the environment can be used, because otherwise like we need a lot of environments to do other testing. So this kind of using this kind of approach, you can save the time, human effort, and even the cost as well. And also like everyone is responsible for their when we are having a performance engineering culture, everyone will be responsible for the performance of the application. Teams can like quickly attend to these issues, and they can fix it. Not only the QE engineers to do the test results analysis part. uh, and also the trending dashboard. So as I told, even the using the trending dashboards, this can be helpful for even for the products, BAs or anyone. And using these dashboards, we can get the maximum benefits. Those are the main features that which we have came across. So I know that we have done only for this API test. We are mainly using for the API testing, and there will be a lot of more things to be done in K6. There can be in this audience also. There can be people who have used K6 for different purposes, and also still we are also trying to use get the more benefits from this K6 and the XK6 features as well, with the trends and technologies which we are using. I think as a SL or with the community, we can have a very good community. So if you know more than this, if you find any more interesting things, we would like to also hear from you. And if you have things that you can share with us as well. And also if you want so we have created public JIT repo with the demo we have done today. So if anyone is interested to get it, we can share it. Anyone is welcome to get that and use what are the things that we have came across, and how we have come fix the issues for the some limitations. So I think Paba will share the details for you to get the request for them. That's pretty much about the things that we have done. You can share your questions.
Thank you for presentations. And um, second, file and call
Paba, you are not
your guest. If one of you
clear to
can
us.
please. Oh, hold on. Sorry, I'm just going to switch off my camera. I think there's an issue with the band.
Sure, Paba.
Am I audible?
Yeah.
Okay, so the first question is how to declare all scenarios in one JS file and call them in your test script.
which means I think that can you repeat the question again?
Of course, it's how to declare all scenarios in one JS file and call them in your test script.
Okay, we recommend it not to have it all the things in a one JS. They can have multiple JS, because when it comes to the performance scenarios, they can have it like kind of a module, and then they can call it into a one main JavaScript and run it. Uh, like in what Sahani has explained it, there are different modules. So in her scenarios that she has pet, then the user likewise, but then everything can be called using a one main JavaScript. So the I we can share the code with you. So if anyone is interested, ask because it was mentioned there. And also,
Awesome. Thank you.
Sahani.
Anna, sorry. I'll add some bit more to that. If in case, if you got any situation where you have to add more than one scenario, in that case, you can add it in this way. Like after this scenario, you can add your next scenario. Sorry, I'm not sure sharing the screen, right? Sorry. Let me share my screen. So hope you can see my screen. So if you are having more than one scenario, I mean, if you get any situation where you have to add more than one scenario, then you can in this scenario section, under the scenario section, you can add your scenarios. You have to give a unique name, and like this, if you have another scenario, you can get it like say you have another one here, then you can give it with, let's say I'm giving it this way, and you can define your another scenario. And so when you want to call it, so if you run this test file, both of your scenarios will be executed just normal way. So in the main file, if you need to run it, what you have to do is in this main file. So here, if we have this test file, say this is the scenario we have. So if we have another scenario, we can call it, we can call that name. Here we have, where I have, I have added the new scenario here. Sorry, I can, let's say here we have added a new scenario. And 1, 2, and we can call it here with that, we can call our new scenario in this main file. So you can run all of your scenarios with this way. If in a situation you got. Hope we answer your question.
And if you need more clarification on that, I've just dropped our email address on the chat. You can reach out to us via email too. Our second question is open to both of you all. How to give percentages for multiple scenarios?
So in our case, actually we don't, what we are doing is we don't give percentage for the scenarios. What we do is we are configuring it with the target value, the throughput. So if you have multiple scenarios, still you can give it in the same way. For the scenario you have, you can give the required TPS for each scenario. Then it will execute in the way you want, rather than giving a percentage. If you want to have your one API to be run on 1.2 seconds, you have to configure it with that. And for another scenario, you can configure it with that your target value. I mean, in this stages section, you can configure your throughput amount in any scenarios you have.
Understood. Awesome. Two more questions. The third question is how to run multiple scenarios with different CSV files, either through options or command line.
If you have more CSVs or scenarios and CSV, that's also you can do it in the simple way, because I'll get one this. So in this case, you are given a CSV for this setup. This function. So if you have another functions like this, You can import if you have another CSE, you can import that and you can use it in the same way in your next scenario, next function. It's the same way you can do it in any multiple times. Only you can change the
Great.
CSV here and getting that value in your function.
Awesome, awesome. So since we're running out of time, we're just going to take one more question. And that question is also open to the both of you. The question is how to also measure the minimum network bandwidth.
Uh, So I think that question is regarding the like it's not a very detailed question. If it is asking about the measuring the that network related thing if you have any APMs you can use the APM, or like if you are using Windows you can use the Perfmon or Wireshark tool. And also like if it is the testing related stuff you can use the like there's a uh, tool called uh, uh, IF-top for like which is recommended by K6, so that can be also used to measure the network bandwidth.
Great. I hope that answers the question. So since we're running out of time, we're just going to wrap up for today. There are more questions that need to be answered. So what we're going to do is we're going to um, get all of that into a nice little PDF, and we'll email it to you, to whoever that's present here. But if the person are asking this question, since it's an anonymous question, if you can reach out to us separately via email, it will be much easier to get to answer your question. And with that, ladies and gentlemen, we're going to wrap up PerfUp 5 with the PerfUp 6 teaser 2. So our next PerfUp event will be production monitoring and performance testing in production. This will also happen really soon. We'll keep you posted on the Sysco Lab social media and on our meetup group on when this next event is going to be. Again, it's going to be on production monitoring and performance testing in production. So thank you all for joining for today's PerfUp event. And a big thank you to Roshali and Sahani both for taking us through a very insightful presentation for everybody present here. So see you at our next PerfUp. And do reach out to us if you have more questions, if you need to clarify much more of the information that was presented to you today. And like Roshali said, if you need to access any of the information that you shared today, please again reach out to us via either email or through the Sysco Lab social media channels. And so, yes, thank you very much, Roshali, Sahani, and to all of the audience members present here. And good night, and see you at our next PerfUp.